Back in the middle 1960s, Philips brought out a small range of electronics kits to enable younger electronics enthusiasts to build a number of electronics projects on a baseboard containing a number of common components. As the radar room is regularly asked at events how one might start experimenting with old valve technology as opposed to simple projects containing either transistors or integrated circuits, hence the idea was hatched to make a series of short tutorial videos which feature a similar idea of a common unit that various experimental valve projects can be installed upon. Unlike the Philips plan of using a hardboard base unit, as we'd be using higher voltage components, it would be necessary to build the basics onto a metal chassis, along with a suitable but safe power supply. With safety in mind, the decision was also reached to keep the high tension circuitry down under 100 volts. This ordinarily being found in the region of 250 to 350 volts. One other issue we had to resolve was the difficulty in obtaining obsolete components. Hence we tried to ensure that everything could be sourced without too much trouble, the primary sources of course being old radio sets and amplifiers. We've given the full circuit of the chassis base unit here, along with a comprehensive parts list, although there's plenty of information online if there are any issues found with sourcing a particular item. We assume that any instructor attempting to build our project ideas are fully conversant with safety issues pertaining to building with mains equipment. We also suggest a grounding of having experience of building transistor or IC projects already. Unlike the Philips project, our ideas are not suitable for young people and should not therefore be considered as such. This is our chassis which we have built. What we have tried to do is incorporate all the holes which we may need for any of the projects. On the inside we have already put grommets in some of the holes. There are two valve sockets here. These are for octal valves, although for anybody following these tutorials they're quite welcome to use smaller, more modern valves if they wish, or even smaller ones. There's B9As, B7Gs, these are called octal. There are slightly bigger ones, but this is what we're going to use for the benefit of these projects we'll be making. Here is a collection of components which we'll be using not to build the first project, but these are the components which we require to make the jig work, so we can then build our circuits with these parts already fixed to the chassis. Run through them very quickly. This is an octal valve socket. We'll be using one for almost all of the projects. We'll probably put two valve holders in if we run enough of the projects to make us need a second valve. So that is an octal valve socket. As I said before, you can use a smaller B9A if you want to use more modern valves. Mains side, we need a little bit of mains wire. This is the mains transformer we'll be using for the valve heaters. Now it's 6.3 volts, which is not a common value found these days. Normally you would find 6 volts. That's about the closest one finds. But not to worry, if it's slightly below, if it's slightly above, it doesn't really matter. It can be much smaller than this. This just happens to be one that I thought would suit very well these projects. The second transformer is for the high tension. Now this little fella here only gives out 28 plus 28 volts according to the details on the back. However, once rectified and once it's smoothed, it gives just under 100 volts. So that will do very nicely for a high tension, which means the maximum that we have on our project at all would be what this little fella gives out, which is just under 100 volts. So one should always be careful when working with valve equipment. Tag strips, difficult to come by these days. You may find another one. You could use Varios strip, put some Variboard and cut it up and make a strip. Once again, tuning capacitors. These are modern Vericon tuning capacitors. If you want to use traditional airspace ones with big vanes, aluminium things, terrific. I'm simply putting these in because we're going to use them in the project to show that the project will work fine with them even though they're modern components. Meter, you might question. The meter will tell you a lot about how well the circuit is working. Obviously, as you're experimenting, you'll find this extremely useful. We'll have it, this is currently a 1 milliamp meter, but we're going to set it at 10 milliamps full scale deflection because that's the maximum we'll draw from the HT. and that'd be extremely useful to tell if your circuit's working. There's certain other factors you can see about how the circuit is working properly by using the meter, so I think considering how cheap they are these days, there's no excuse for not having one. Main switch. Socket for the, well, two of these actually needed. There's one for the input and output. Once again, you want to use a small socket, 3.5mm, that's fine. Doesn't matter at all. I'm using it because I have an adapter. I can use 3.5 or this standard size here. Volume control. We'll be using that as a volume control, timing control, all sorts of things. 1 meg is the thing which we use mainly for valve circuits, because valves are relatively high impedance compared to transistors, so a transistor volume control will be 5 or 10k. This is 1 meg. 2 sockets, variety of uses, error alert for example. Fuse holder, imperative. You don't rely on fuses in the plug when you're making valve stuff. So you need a fuse holder, any sort you like, make sure it's safe, and that will be inside, so everything from the mains will be coming through that. LED, a modern addition here to show it's switched on. If you want to use a light bulb, that's fine, but certainly I'm for convenience using the LED. This last transformer is what we call a speaker transformer. Now this is the matching between the valve and the speaker. Obviously, to have a correctly operated transistor or valve circuit, everything must match properly, but for what we're doing here, for all intents and purposes, if there's a mismatch, as long as it's not gross, it will work fine. So likewise, the HT is going to be a lot lower. Normally most of these circuits would be running on 230 to say 300 volts. That's why we're going under 100. So the fact that we're using this, if there's a mismatch, it's not going to do the valve any harm, and it's still going to work fine. So that is our speaker transformer. Difficult to find these sometimes, so what you want to do is find something with about 400, 500, 600 ohms, which you use for the primary, and then the secondary is the speaker, which will be 3 ohms, 8 ohms, take your pick. So you're sure to find something looking around which would fit in this department. A transistor one will not work because usually they're too low, the resistance and the impedance, of the windings. So there we go. That is what we'll be mounting inside the box, and from there then in a minute you'll see what it looks like with them all in position, all wired up. We can check it out, make sure it works, and then in the second of these videos we'll make the first project. Should you decide to have a go at building one of these chassis units, it'll hopefully come out something like this. It's up to you, of course, just how you lay out the front panel and the components mounted on the chassis at the back. We hope to soon have a range of simple valve projects in this series to build into it. Thank you for watching.